Let's do another round of practicing Haskell by using CodeCrafters. This time I want to try building the grep. And spoiler alert, we're going to use parser combinators. There's going to be probably a lot of debugging and a lot of refactoring. Welcome, welcome. Let's use Haskell. Just intermediate, proficiency, practice, pass, continue. Clone, done. Okay, the first stage where we uncomment some stuff. Alright, first thing first is, which gives us GC925, which probably tells us that it's not HLS powered, maybe not very supported. If we go to 928, we risk breaking things, but at the same time, so let's just do something they tell us not to do. Well, while we're doing that. So everybody's favorite stage is uncommenting the given code, removing the comment, and committing. Let's just add an app and not everything. Ignore stack for now. Hopefully it's not gonna backfire anytime soon. So we said that the stage is complete, but they also say that the basic thing to run it is echo something into the script. With an apple and an A, we get blue dot, which I assume it's good. And if we run, there's no B and apple, we got a little X. Okay, next stage, we match digits. In this stage, you'll implement your own solution. You read the instructions and ready to do this. D character class. Any digit should match 3, but not C. Executed with apple. There's a digit, so it's good. Let's see if it works already. Okay. Oh, it's unhandled pattern. Nice. I'm still not sure what we're doing. We have a pattern and an input. If the length is this one, then we do this one. We do something else. Pattern equals 1. Okay, so we have a pattern for a digit, which means we can pattern match on the pattern. And if we got a digit, we're gonna do something else. But for now, let's do the rest. Otherwise, it's gonna be fallback into what we had before. This should not compile yet, but single with a list means just a head, and we can do what we did before. And otherwise, we're gonna error as we did before, and the rest is left is the undefined for the digit. Head becomes a single, and this can be dropped. Then we need to make sure that anything inside the input is digit. Yep, data char. And it takes a boolean condition first, and then the rest. Okay, digit works. No digit does not work, and the A still works. If we push, we see that everything worked fine. In this stage, we'll implement support for the /w character class, matches any alphanumeric character, a z, and this. If we switch back and slowly try to run it, we should fail and handle pattern. So we can speed run this. Instead of digit, it's gonna be W for all alphanumerics, and the same we have a function for is alphanumeric instead of is digit, and check echo works. We can commit and see if it actually worked. I think for now we're lucky because data character implements all the functions we need for completing this exercise for now. For now, we're on a roll. Positive character groups. Okay, I don't think there is positive anymore. And now we actually have to start implementing stuff. First thing we need to do is parse the pattern itself. And at this point, we have to start doing the actual work. By doing work, I mean, instead of mixing the two, I want to split those into two different things, the left and right. So first function I want to extract is parse pattern. That's going to take a string and return some sort of pattern. The function for most of it is going to do the matching on the string. We can use lambda case, and the pattern is going to be something, for example, just a digit first. So in the first case, we're going to return digit. Then in second case, we're going to return alphanumeric. It's going to be digit or alphanumeric. And then the next case is going to be single or single character. Actually, single character. So we have the character we can use later. And so in this case, when we match, it's going to be single and the character itself. And the last case, error with a pattern. POP doesn't matter. Let's actually just let's return a maybe pattern. In all the cases, it's going to be pure digit, pure alphanumeric, and then it's going to be pure single. And in the last case, we're going to return nothing and don't throw an error here. And in the other case, we're going to do the matching. We're going to take a pattern and the strings that should be matched on, which is an input, and do the matching, something like is matching pattern. And instead of maybe pattern, let's return a boolean. In this case, we need pattern match on the pattern, and If it was a digit, we do what we did for digit. It was alphanumeric, we do what we did for alphanumeric, and then last case it was a single, we check, and the last case shouldn't even happen. So if we clean this up, we can use two functions. So first we pattern match on the parsing of the pattern, and if that was successful and we got just the pattern, we can is match pattern on it using the input. And in the second case, if it was nothing, we didn't get anything interesting, we can keep an error for unhandled pattern for now. Okay, with that out of the way, let's implement the new positive group. New positive group is going to be a list of character, which is a string in Haskell. So maybe we can just write a string, but it's kind of awkward, confusing. Let's just keep a list of characters to be explicit. So the positive group means we have characters. And for this character, we say for any character, it should be an element of an input. And we pass the characters. And instead of single, it's a character. And in the parsing part, for now, let's just say it starts with a square bracket, then it has whatever, anything else, and then we just pass in it. I don't think it's good because we're not checking for closing, it's bad, but I think it should be able to parse the basic cases for now. We can start with this and then immediately refactor. So echo apple works, BC does not work because we don't have an A, and then if we, is it digit or something from the past still works or not? Yeah, it still works. So let's just commit it and refactor right after. I don't think it's sustainable to have this. It's gonna get worse, so let's just refactor. If we open the dependencies, we can see that there is megaparsec, and this is the one that we're gonna use. Before we jump into that, let's move things around. First, I want to extract the pattern parser. The pattern parser is gonna have the pattern itself and the parse pattern functions that we just created and gonna refactor. First, we need to export pattern and we need to export the parse pattern and then use it in the main. We're gonna use the pattern and then we're gonna use the parse pattern. So megaparsec is quite well documented, but I think what I remember more is there's a tutorial by Mark, which is really good, and I'm gonna reference it probably more than documentation at the beginning. First, I want to grab all the imports, and we need the declaration. First, it suggests to get overloaded strings. I'm not sure if we're gonna use it or not because it uses tags and we use strings, but let's just import what they have and import all of this. First, we need to declare parser. It's parsec, which says void for errors because we don't have any custom errors, and text as the input. So let's just move it down. We need to create a parser for each of our patterns. First, let's start with the digit. Parse digit is a parser for a pattern, but it's gonna return just a digit, which is a digit, and we create it by combining character parser for a backslash, followed by a character parser for a character D. And then first we do one, then we do another one. If both matches, then instead of getting this result, which we don't care about, we just want to go left to the digit. And going left to the digit means we just discard the result of parsing the characters and getting just the digit. And we're gonna do the same for alphanumeric. Instead of returning a digit, return alphanumeric. Instead of matching on the D, we match alphanumerics. And then we need to combine both of them using alternative. First, we try to match first one. If it doesn't work, or alternatively, we fall back to another one. If I remember correctly, we have to do the backtracking ourselves. Some primitives already handle this, but I don't remember which ones are which. Just let's refresh. In the tutorial, it mentions that there is AB and AC. It tries to do AB, and then if it already goes and commits into the branch and fails, it fails. Which with try, we need to tell it, okay, just go back and try another branch. So we do try. And in other cases, something similar. We try to parse digit. If it doesn't work, we fall back / backtrack and try to parse alphanumeric. The next thing we need to do is parse positive group. It's a bit more complex this time. We can use do to build a bigger parser from smaller pieces. In between, we're gonna have to match characters, probably many characters, and I'm not sure. Let's put undefined for now and says that we want to return pure positive group of characters. If I go back to the documentation, we can use something like single, which is just matching one token. In our case, one character, or we can use any single that parses and returns a single token, or something like any single but that returns any single but the one that we want, because we want to get rid of the bracket. We don't want to match it. So we use any single but, a closing bracket, and then go to the bracket, and then we add the parse positive group to our parse pattern. The last thing that's left to do is to do another copy paste run and implement this single. Parse single is gonna return single, and instead of matching specific characters or things, it's just gonna match any single. And instead of this applicative, oh okay, it's messing parse single, we're gonna add it to alternative group, and then it's still not matching because character is not matching. We need to, instead of discarding, we need to wrap it, because the single, as you can see, we want the character as well. We want to wrap the characters that we got into a single and not discard it. And we need to do is to combine everything together into parse pattern. Just to make it nice, let's rename it to the parser. Move the parser again up and down. It's gonna stop moving it around. Move this into where, because it's kind of convenient to have it here and names are awkward. And we're gonna use parse maybe on a parser, and it says text is not matching with a string yet because we're given a string and we train text. I think the easiest thing to be is to just switch it to a string and remove the text completely. In case of this parser, it's fine because both text and string work on characters, so it should be easier to change at the end if we don't want to or don't need to, but actually using the pattern and parsing what we need to parse. Here we have a negative character group. And negative character groups match any character that is not present within a pair of square brackets. These should match a dog, but not cap, since all the characters are either A, B, or C. Your program will be, again, we have a situation where we open a square bracket and then we have to choose either we going with this or we going with that. First thing we do is the usual copy paste, change the positive to negative. And here we're gonna start with negative first and with a try, because we've seen that you could do a bit more than you need to with a caret. And then the second thing we need to parse is this little caret and change the negative to the negative group and return negative group instead of positive group. This should be it on the parsing side, and on the actual matching side, it should be as simple as the previous one, but instead of any, we can say not any, which kind of means that all should be not char element, which means actually not element, and then this could be removed and we get something like this. Maybe we can swap the character and input so we can read it other way around, like all characters in the input are not part of characters, but I think the other way around as we had before is fine. All the characters not element of an input. Not element for Apple works, and previous one still works for Apple, and then if we could not Apple and we drop an A, it should also work. I want to refactor it a bit. If you look at the docs, we can see there are some ring sports from the combinators, and here I know we can find way more fun stuff. We already use alternative, we not use empty. We can use between, that gets an open, closed, which looks pretty fun. What's the difference between symbol and a character? I don't know, but there's a choice that takes this counts and buys many till until succeeds some many options separated by skip many. Let's try to use between. Opening bracket, closing bracket, and everything in between is gonna be something like many till. Gonna take only singles until we get to the character, which is and close bracket, which kind of what we can. So we can wrap it all in the positive group. We don't need this, doesn't compile, maybe parentheses. Parentheses don't help, let's add a dollar as well. Yeah, so we need to get the group and then wrap it inside. I'm not sure this many till feels kind of verbose, but maybe let's just roll back to single but a closing bracket. And then the positive groups looking the same, we open and close. This time we use a string with opening bracket and then a caret instead of just opening bracket. Everything else looks the same. We can extract the group. Let's just completely extract it so we can use it in most cases. So we just do a character group. Type signature, not what I wanted, but I think it should compile in both cases. Let's just use parser instead of all of this, and it's token, list of character. List of characters is a string, so we can say token of a string. Let's give it a try and see if the refactoring still worked. And it did. So it's complete, and I'm ready for the next phase. Fetcher will start to feel useful. Keep in mind that it's harder than it was before. You might need to rework stuff. and process user input character by character. This matches 1 apple, this matches 100 apples but not 1 apple, this matches not present, and then we have more complex expressions. I think on the parsing of the pattern side we are good. We already know how to parse one, we just need to parse many of those, and then as a result we're gonna get an array of patterns instead of one. On this side of getting a pattern, we're ready. We just need to adopt the other side. That's where we changed everything else now. So pattern is going to be just pattern, so we can reuse it in the pattern parsing side and then the pattern validation slash whatever matching side. Let's fix all the imports. We need to import pattern with the pattern we just created, and then the pattern parser keeps only the parse pattern, the functions that we had before, and P is not matching because the function changed. I think I want to get all of this is matching and match pattern and move it in a different module so we can have it all in one place. This pattern matching function is going to only expose the is matching pattern with a similar type signature, but we're going to change the insights later. Re-export it, and then we keep is matching pattern. Let's change digit to undefined, this one to undefined, and everything else to undefined, but keep the structure as a pattern match. I think the whole thing could be just from the pattern to a new parser, and the parser is going to be returning a string similar to the previous one. The input is going to be an other function, and we can call this something like toParser or a parser. toParser, yeah, I think it should work for now. And then to make it all compile, let's bring the is matching pattern back. Just keep it undefined for now to see that everything is working together. And then let's implement the toParser. I think we can use something like single for digit. I'm actually not sure single what is a digit. So let's just try single character first. Single character is easier because we only need a single character, and character doesn't match an array because we want to return a string. So we can lift one character into the string with a pure. For the rest of it, in the docs, we can see that there's alphanumeric character and digit character and all the other specific cases. I think for now we only need the digit and alphanumeric. So in case of digit, we're gonna use a digit. We're gonna use a digit character and lift it with a pure from a character to a string as well. Similar for alphanumeric, here is gonna be alphanum character. And in case of positive group, we can use one-off. One-off, we can pass a list of characters. And once again, it just gives us back a character, not a list of characters. Yeah, I think all of it is gonna return a list of characters or a string, which I think we can refactor. So let's keep none of, and then change this parser for string to parser of a character. And then we can get rid of all the pures. As Simon was talking about, it's going to be character by character. So it's going to be a character parser, and then we're going to use this character parser to combine into a string parser. So our string parser is going to take a pattern, probably a list of patterns. Each pattern is going to give us a parser for a string, a parser for a character, and then together we're going to be combined and get a parser of a string. So we need to do something with a character parser. I assume it's let's see if it can guess. Yeah, it is traverse. So it's just a traverse because we have a list of patterns and we transform it into a parser of the list of characters, and the list of characters is a string. So we just using traverse to combine them in this way, and the comments are not needed. We can just drop them. So our is matching pattern changes to a list of patterns. It takes the patterns, and then we can parse maybe patterns, pass it an input. It's a boolean, so we can just convert it into is just, import it from that maybe, and actually convert it into a parser. I think let's just call it from string parser from, and character parser from. To make it more explicit, we can drop inputs and compose this into a nice little function. If we go back to our main, we can use is matching pattern, where it's not just a pattern anymore, it's a list of patterns. We need to, our previous one was not imported correctly, we need to import pattern parser. And then we parse the pattern as matching, and then we get this. And I think in previous case, it's kind of annoying that it returns just maybe in case we need to debug or see better issues. Let's just convert it to either. Run parser is going to return an either, which is not a string, it's a parse error bundle, which I'm not sure what it is. Just keep it a string, and let's just keep it strings and see if we can decode it. It wants not that it's a pattern but a character. I think it's the first error or a first, so let's just pass an empty string. And I think this is also not a string, it's a void, and now it all compiles. I'm not the biggest fan of idea of leaking this parser error outside because it's probably just going to be shown. So let's just pretty print it right away. I think error bundle pretty is what we need. We just need lmap our either, and it's going to give us a string. Lmap is not important. I'm not sure where to import this from. We can use first. It's the same. It's the same, and I know byfunctor should be here. We can import it from byfunctor, and just going to be modifying our error. And here we can compose, and the parse error bundle becomes a string. So we're gonna return either stringy error or a parser. And now it's not a just anymore, it's a right patterns and left errors. And let's say something like unhandled pattern and return a pretty error. There could be other issues, but so let's say just or something else, so not to be confusing with error, because there can be other issues. If you try to run it, this does not match because it doesn't have anything. Should it have matched? Wait, or this one doesn't match. This one also doesn't match. Wait, so most of them don't match. Let's see. We can add a show debug to see, or trace debug to see what kind of is a pattern parsed correctly or not in the first place. The show pattern is missing. We can derive show so we can see it. And if we run it again for the apple, yeah, it's a right negative group as expected. So the problem is at the matching part. Somehow we have a negative, yeah, it's like negative a. Yeah, so we only want a negative group, but we have an apple, which is more than just one character, and we only match in one character. So if we have a pattern with more than one character, we're not going to be able to match it. We need to somehow drop or skip, or yeah, maybe skip. Just ignore everything we had until that point, then our match, and then ignore everything afterwards. So something maybe like skip, yeah, skip some, skip many. Let's say we skip many till that we're gonna get all the random any singles. I think any single should work. And then we're gonna get to our pattern, then it's gonna match our pattern, and then it's gonna tell us, like with a grep, like this red, the color for pieces is the one that matches, and everything else we skip, and we say, okay, it matches, but we ignore it. It's not what we need. We might need to try to backtrack it, but I think it's fine for now. Let's just run and see if any progress. Apple is not working as expected, and no apple is also not working. Let's actually try to parse something and see what it parses. Run this simple parser on simple inputs and see what it outputs for just a test. Okay, let's create a simple parser just for the digit to see if the basic thing with array works or not. So if we pass a list with a digit to our function string parser from at before, that we need to export string parser from and import stuff to make it easier for JCI. Maybe we'll redo later, but for now it's good. So if we parse 3, we should get fine 3, right? And is matching should also give us, if we prefix with a3, for example, it works as well. And then if we close it with something, it works too. What about -1? I think that's the one that was not working and the maybe problematic one. Or test parses 3, we should get back at 3. If we add something negative, we still get at 3. And then if we add a suffix, it should work. Yeah, it still gets it. Okay, like this seems to be fine. What about parse maybe? The one that we actually doing is this one gives us what we want. Oh, so this one is not giving us stuff, even though, so it works for a single character, but for multiple characters it doesn't work. So we skipping, so we have this 3c, and then we skip all of this and we get to the end, and then we return nothing. Because what's probably happening with part test is that is different from parse maybe on its treatment of the end. So we skip through this, and then if we get till the end, we get nothing, and then it returns nothing. While one thing that we can do is either play with an end here, somehow say, okay, we got to the end, we didn't find anything, return whatever. So at least we need some kind of positive confirmation that we returning stuff. Or we can say just get me anything, and anything is gonna include end of line. So we can say, okay, we got till the end, didn't find anything, but at least don't fail, like give me many whatever, and you didn't find anything, but don't fail. So let's try this thing and see if it works. So if we create a string parser from single A or single B, running just AB should still work. Running ABC works as well, and if we prefix and suffix, it works as well. Okay, what about the negative situation? Exclude ABs. If we put C inside, it works. Another C, well, it's kind of unclear which C picks. C in front, C at the back. Okay, so we get stuff. Maybe not fully actual grep yet, but should be good enough to pass the tests. Let's move this and move that. Oh, cool, we don't need these parentheses, and everything else looks good. Let's just commit this. This passes, and we don't need to refactor anything for now. I think it's good, we can move to the next stage. In this stage, we want to support start of a line. So if we start with a lock, it should match. If we don't, it's not. Let's see if this magically works. Okay, it doesn't work, and also I forgot to remove the trace, which I guess doesn't hurt, but it's also nice to know that we can reuse one of the existing parser to create a new start of the string anchor parser. This one should be as simple as getting a single character, in this case the caret, or just a character, which becomes start of the string anchor, which we need to add to the other patterns. And then if we go back, we need to add it to parse1. I think this could be refactored. We've seen that there was a choice where we can pass an array and then it's gonna put the alternatives in between, so we can just use choice. Replace all the alternative operators with a comma. And now we need to decide where to put the start of the string anchor. It should come before parse single because it's another character, and I'm not sure we need to try because it's just one. So we get start of the string anchor, single, single, single. The problem though, if you want it inside, it's not actually what you want. In description it says that it doesn't match a character, it matches the start of a line. So technically I would call it fine and move on to the implementation of the pattern matching. Now the question is, what kind of pattern is the beginning of the line? The first thought that comes to mind is that if we have a list patterns and start of the string anchor is not first one, then it's bad. And if it's the first one, then we shouldn't skip many. So here's the idea. If we pattern match on patterns and the previous situation we keep the same, and in the case that we start of string anchor somewhere in the beginning, and then we skip it, and then we do the rest of the patterns, we don't need to skip many anymore because we need to start from the beginning, we keep the rest. The undefined then becomes some sort of no-op, where maybe we can say just this, which is this legal? Not sure. Oh, no, that's true. I was just testing if it still works. So this one passes, and this one does not pass. Wait, no, this does not pass. Let's test it and then maybe refactor a bit. So it does work. Maybe let's refactor because it's kind of useless to have the same thing twice. Let's extract the rest and maybe extract the middle part where we trying to match the pattern with a try and traverse. We need to pass the patterns in the first and second situations, they're different. And we keep the skip many till any single in one case and we don't do it in another one. In theory, we could extract the skip many till part because it's just the stuff around and then returns the parser. And then the first case we don't do it and the second one we do it. I'm not sure it's helping much, and in this case it's clearish enough. start support is complete, let's add the end support. Probably we might not be able to get away with a simple solution this time. So the idea is either we do something similar, some special handling of the pattern, somehow saying if there is a pattern, it should stop doing this part, or we do it here and we say end of line or end of file or end of whatever, and even if it's in the middle of somewhere, it's just gonna stop. Okay, first problem is that instead of getting character here, we get a unit, which doesn't match with what we have. We need something like this. We say return a parser that kinda go back to what it was before and then end of. Okay, so this approach does not work. Parser of end of input. We need to restructure this, and instead of returning instead of working with the list, just using traverse, I think we can do a good old go pattern. We can go through the patterns and then accumulate, and we can look at each pattern and treat it in a special way. If there is start of string anchor, we use it as a skipping point, skipping this whole skip many till. Then we're gonna have special case for end of string anchor, and then another case for the rest. In the case of the rest, we skip many till like we did before, but instead of passing the whole traverse and tries, we just parse one specific pattern. We get what we need out of it, and then we need to continue. We pass the rest of the patterns. We need to combine new parser with accumulator, which is parsers and parser, which we need to lift with lift a2, and switch accumulator new parser. Then we need to do something with the rest, and we need to do something with the start and the end. The end is just accumulator followed by end of. That's it. It should just return what it had before and stop. Start should be similar to this one. No, maybe no, it's too much. It shouldn't skip many, so we don't need new parser. Actually, the whole parser is not there. It's just skip it and go do the rest. The only problem is that if you have multiple starts, then it also not very... There's an invariance, which is not very nice for the case of having start only once, not twice. If it happens more than once, then it's kind of not nice. We can remove this and use the go pattern by passing patterns. Oh, it's other way around. First we pass patterns, and then we can use empty parsers that doesn't do anything, then we start accumulating the parser. This plausible, this not the most beautiful parser or code ever seen, but at least let's hope it does the job, and then maybe we refactor it. But before we do that, we need to add another parser. And it doesn't work because we didn't add this. This still doesn't work, even though it's parsed as expected. Single, 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 and then end of a string. In this case, it's such a clean match without any stuff before the doc or after. I think it's just not working, not because of tries, but just it's not working. Oh, okay, so in this case, it's just not good, right? So we skip many till, and then we put it back again, and then we keep skipping this all the time, because this code is mixing two cases of first parser, like this, and then first look at this, and then middle ones like ends and the rest, which isn't good. And that's where also this issue comes from, and then doing this twice comes from. Okay, what if instead of returning just a parser here, we do intermediate step where we accumulate all the patterns? This part we do inside, and then we do skip many, all this later. We just try to represent it better. Instead of saying the pattern is one of those, or a list of patterns, somehow represent it differently, because we can only have one start and we can have one end, and both of them were not matching in any way. So if instead of treating it as another pattern, we treat it as something else, so we have some, I don't know, collection of stuff, and we might have maybe a start anchor, maybe an end anchor, which is just a boolean, but still, and list of patterns like we have now. And instead of passing list of patterns around, we're gonna pass this around, and then when we parse the things, we're gonna accumulate the patterns and then say this once or twice, and they'll deal with patterns. On the matching side, this is gonna stay the same. This is gonna move out, this is gonna move out. And we're gonna do it once, and then the rest is gonna be like it was before. On the parser side though, we'll need to change the parser. Instead of returning here a list, we'll have to return our new thingy, and this will have to be inlined. This sounds reasonable. Let's keep it as data. One for the start, one for the end, then derive show for one, for another one, and then for patterns as well. And it fails because it wants empty data deriving. Let's add a pragma with empty deriving, it should work. Extract this parse patterns as parse patterns. Parse. We move out the parse one, is going to be the core of it or the middle of it, and then we can go through our parser step by step. First, we're gonna start with a start anchor, then patterns, which many of these one thing is, and at the end it's gonna be end, and we assemble into patterns. Maybe start anchor, list of patterns, and end, and maybe end anchor. To tie this all together, we need to fix run parser. It should be just passed around, and this needs to be moved around and committed out. So the core of it is here, so technically we just need to fill out the gaps. We need to expose start and anchor data types. And this should be optional now. Optional. I think we actually want one constructor. Okay, let's do it the other way around. This is optional, which means we can do like we had before, just character, map it, or rewrap it, redo it into the anchor, and then make it optional. Similar for the end. We can drop this. We can actually use both the parsers instead of undefined. And if we go back to our Go pattern, we can revert everything we've done. We actually don't need any of this. And this we're not gonna need because the pattern, it's not a pattern anymore. So instead of list of patterns, we get just our patterns. If we can import these patterns, I want to get the part of it using overloaded record dot. So let's enable the extension. Now we should be able to say that patterns. So first, what I want is something like we start. That's pattern match on the patterns start anchor part. And if it's defined, if it's just something, that we're gonna do one thing, and then if it's nothing, we're gonna do another thing. In both cases, we can just use IDs for now because it's gonna be like wrappers. And in case of with end, it's gonna be similar. We're gonna pattern match on the pattern and anchor, and if it's there, we're gonna do this or that. And the end, I want something like this. We have we start, which is gonna wrap around this try matching, the core of what we had before, which is just patterns part of patterns. And then at the end, we're gonna wrap it around with a with end. This is not working with a beautiful error saying that there is no instance for has. Oh yeah, we just need to import everything for the patterns. We don't need the rest, we're gonna inline this. So for with start, if there is nothing, we're gonna skip many till like we did before. And then with end, we're gonna take the rest that we wanted before, but we're gonna discard the rest. I think we need to wrap it around to make it the function. And then inline this because it's gonna be any single. And for the other case, when we have just, that's where we wanted our end the file if we wanted before. It doesn't work. I want something like this. I want a function that takes an x and then discards it. Why is it not working? Oh, it's not working. The parentheses were wrong. We want to wrap it around this, not in the middle. So it's going to be similar for this. Take something and then discard the rest. So if there is an end, we expand end of file. There is no end, we expect just many single, but we throw them off in both cases. Clean all of this up. So we run this and it's not working because the end is considered to be just a single, and I think we need to ignore it as part of single. Should be ignored as a special character. And maybe we add the caret as well. If we run it again, it correctly interprets it and we can submit the assignment. This time we need to parse a plus one or more quantifier. A plus should match apple and SAS, but not dog. We already seen some which matches what we want, one or more times some pattern. The thing that we need to implement here is the parsing itself. I think for now, mostly we've been looking at one thing at a time, one character, and maybe what comes afterward. But this time we need to look kind of at what comes before or after, so a bit different. The simplest approach I see is to try parse one thing as we did before, and then try to parse a plus afterwards, optionally, and then if we have it, it means we have it. If not, we go back to parsing what we've done before, and then we try this multiple times, because you can have multiple parents and multiple quantifiers with a plus. It seems like we'll never leave this poor piece alone. Let's refactor this again, so we can easier extend it. If we go back to pattern, we can add one or more, and this time it's going to take another pattern. I think it kind of makes sense that we can have one or more digits, one or more single, one or more. Yeah, I'm not sure about positive and negative groups. Actually, why not? Yeah, you can have positive group one or more times and same for negative, so I think that's what we need. We can make a function for parsing quantifiers, which is going to be a parser that returns maybe a pattern. One special case is going to be parse one or more. That's going to be return parse maybe one or more. But because we're going to have plus, and I've seen that soon we're going to have another one for 0 or more, it makes sense to just keep them together. First thing we need to do is to get any single, which is going to be some character, and then we pattern match and see if this character is a plus. In this case, we're going to return just one or more, and we said that we're going to return or wrap around some pattern, which means the easiest thing to do is to pass this pattern together, some previous pattern. So we get a pattern and we return a parser of maybe a pattern, and then we lift it with a pure, and then here's a nothing. The problem is the nothing case. It's some sort of fallback. We're missing some sort of a fallback. If we didn't use any pattern, or if we didn't find any pluses or something like this, it means we need to kind of go back and return just the pattern itself. Instead of returning this complex pattern, it's just going to be a simple one. I think we can extract this part of getting maybe quantifier that gets one character, maybe probably one character with any single parses, and then wrap stuff around. And if it didn't find anything, we have nothing, then it's gonna fall back and return just the previous pattern itself. Something like alternative or else, which is not what we need. And probably at this point it's easier to get rid of the maybe all alone and just return parse of a pattern. There should be something like option, not optional, but option, where we say one pattern or the other one. This does not work. Maybe other way around. Okay, other way around. We have option, then the default value or fallback value, and then the one that we want to try. We should probably sneak in one try here or there. Here's kinda, yeah, let's just add it here. So we parse quantifier by saying maybe there is a quantifier. If not, it's okay. But if there is one, we're going to return the quantifier plus the previous pattern. Otherwise, we just return the pattern. And then if we go back to the patterns matching, before we used to have many parse ones, and now we're going to have many parse one first. Try to put it in the quantifier. If not, go back, just parse one, and then keep going. So each time we're going to try one pattern, go one up front, see if it's plus and us, go back, which is a bit wasteful maybe, because each time we get +1 looking up front for the plus, but I think it should be not a big deal if it even works. This should definitely fail because we have not implemented the handling case. Okay, we see that there is a C, one or more A, then a T, and then the S. What if we do multiple T as well? One or more A's, one or more T. Let's implement the other part. I'd assume that should be as easy as adding sum and then a pattern. Oh, okay, we need to wrap it in a char parser from, but it's not as easy because we have a mismatch of characters and strings, which means that we have to change this to a string. So each character should be lifted to a string with a pure, and the last one needs to be flattened out. We can add a join to flatten it out, which we need to import first, and then fix a dollar with parentheses. And then traverse is not going to work. We need flat traverse, which Haskell does not have, at least not in standard library, which we can emulate with fmap join. Let's see if cats work. This cat works. Let's see if this cat works as well. And the best part, we haven't broken anything else. The next stage is 0 or 1, also known as optional, and after that is going to be wildcard. I was expecting 0 or more after that, but maybe let's just add it while we're here. We can add 0 or more, we can add 0 or 1, in the matching part should be easy to extend. 0 or more means we use many instead of some, and 0 or 1 means we have something optional, and optional returns a maybe, which we can convert into array using from maybe into list or into list, whatever. This compiles, which assumes it works, and we can change the parser. So the first one becomes 0 or more, and the second one becomes 0 or more. Oh wait, the first one is 0 or 1, the second one is 0 or more, so let's submit. This passes, and we can mark the stage complete and switch to another one. The next one is wildcard. We need a wildcard that matches any character. First we add a new pattern, call it wildcard. Then we add a parser, which takes a character, which takes a dot and becomes a wildcard. And it gets us back a parser for a pattern, not a wildcard. We should not forget to use it, and we should probably use it after the alphanumeric, for example, as long as it's not after the single character. And the parsing should be any single character is a wildcard. If you try a dog with one wildcard, it passes. If you try a dog with D and then one or more wildcard, and then it's done. And then if dog with one or more wildcard followed by G, it's not working. Could it be that we're missing a try? Okay, I guess the case is that we're consuming the G as a part of a wildcard, and then there's nothing left. And no try can save us because it actually matches. Let's admit and see if it works on their side, or what kind of test do they have. Maybe we're just overdoing it because we added some more stuff. But I'm suspicious that it's just not working. We need to address it in another case. Both the 1 or more or 0 or more are not working, because the idea is to have not a back pressure, but the way to say that, okay, we took enough, then take a step back, count -1 and do it again. So I think we need to refactoring, completely change what we have. But before we do that, let's do a small debugging session and see how the parser works. We can use dbg function for debugging purposes from the library itself. We provide some message. In this case, I want just parsing and which pattern we want to parse. And then we can run it and see what's happening, what it's trying to parse, what is the context, and what's the match. If we build the parser from using string parser from using the patterns we just saw, which is single D, one or more wildcards, and then the single G at the end for the dog, then parse the test using parser dog, we're going to see that it gets in dog, and then the first letter successful, then goes to wildcard, then it takes O from OG, then it takes G, and then it gets empty and fails, and it kind of goes back to 1 or more with OG, and then wildcard goes all the way to OG, then 1 or more gets the OG, and then we fail because there's nothing left. The one or more wildcard was greedy enough to grab the rest and leave nothing for the G. I want to start with also taking another look at one more. I think that's the one we're going to extend and play around with. So if we get the characters out in the do notation, and then we show what we got, like which characters we matched on with using trace show ID from the debug, run the parser again, for example, with a dog again, we're going to see that, yeah, it gets the OG. So it gets everything. This whole gets everything, even the G. So I want somehow to have these characters and then say, okay, get the characters, go to the next. Or if it all fails, go back, say count, I'm not sure, like some kind of length of these characters. Some, for example, let n equals length characters, and then we pass this count. Then in this alternative case, we're going to use this n for the length from with the count, and also pass it this whole sum with character parser from, and then do the next. I think the n should be -1. It's not going to compile anyways, but I'm just want to sketch it out to show the idea. Something like this. So we try first with characters, and then if it doesn't work, we try with count n-1, and then if that doesn't work, it's going to be n-2 and so on. But it's not going to work because we cannot pass it, so we need to completely restructure it and do everything again. I'm suggesting to do the call pattern once again. So we have a new match patterns, which is going to be undefined for now. It's going to try to match pattern, and instead of doing it right there before, let's just do it here. Let's make a compile with traverse, but then we're going to change the traverse to something else because the traverse is not working. We want to have a look at more than one parser at a time, while traverse just does one at a time and we don't have access to it. So instead of patterns, we have a list here. Instead of all these patterns with starts and ends, we only have a list of patterns, and there we switch to our match pattern function. let's switch the traverse to Go. Once again, I hope we're gonna keep it this time, but maybe we're gonna refactor it again. Let's see, the Go pattern is gonna take a pattern and the rest. For example, let's start with a digit. If we see a digit currently, we say, okay, do what we did before, pure digit, but then you should do the rest. Kind of the previous logic. What traverse was doing for us, we're doing it by hand. We're gonna say do this and then the rest. And then instead of doing traverse, we're gonna use a Go, pass it all the patterns, and then the rest case we need to pass Go rest. And then for other patterns, let's just keep it undefined or empty for now. The error probably just doesn't like the type, so let's edit the type, and then we don't need any maps or anything like that. Let's just keep a Go pattern. And pure is also not needed, so we just say digit, character, and then do the rest. So we can fill out the rest as well. Alphanumeric is just alphanumeric character, single character, digit, positive group, once again one off, negative group is none off, and all the simple cases are done. We're gonna go to one more. In the case of one more, we can move our sketch of the do notation we've done before. So we still need characters, and then at the end, well, we got all the characters, we're gonna say pure characters, and then we do the next. So in this basic case, oh, we don't even need this pure, we just say do the rest, because it doesn't matter. This is our basic case. We do characters, then we get our lengths as we done before, and then we say do the rest. For the alternative case, the one that we're gonna add now, we want to have count, and then instead of going go next, we say go with the rest. The types don't align, so here we need to add a join. We need to join all of this to change its type, and then add a try on top of all of this, because we need try on top of the first one, because we want to have a fallback. If the first one didn't work, we're gonna fall back to the rest. It doesn't want to be all nice. I think we need to have it here. And here's our first problem. We have a try, the first case, and then the second case with n-1. But the problem is that we don't have access to n-1. We don't have access to n because it's different blocks, different notations, and the cases are alternative independent. So I think we need to change it and use actual state with our parser instead of using simple parser with a state, because the whole parser was already a transform that we used, so it should be easy to add a state inside. We can use something like backoff. So the first round is going to be backoff none, and then all the other round can have something like with backoff integer, unless the ref show, because we're probably going to need it for debugging. So now this doesn't work because state backoff is not equal identity. Probably because we cannot use parse maybe anymore. We need to use run parser t. Let's make it explicit with input. This doesn't work because there's a boolean and string function mismatch. Okay, we still need to pass it the string. If we pass it the string, it still doesn't want it. I think the problem because we need to run the state separately. We need to deal with the state and then run the state, because one more transformers that needs to be evaluated and run. So if we use eval state on this state and with an input for this one and an empty string, a none variable, not in, we need to import the state, and then it's still not happy because state doesn't equal state. We're gonna set to pattern match and see what are we getting left and right as we expected. Instead of, in case of a left, we're gonna get left. It still says that state doesn't equal state. Transformer state. It's possible that we have different states, something like identity is a different state that we bring from the parser, like internal parser state, not the state the monad. If we drop this, oh yeah, it's megaparsec state. Let's just hide it. It brings its own internal state or something. Yeah, right. So let's just remove it, and now we see that errors doesn't equal errors. We done this before with bundling error to make it pretty, and we bring the strict state. Let's make it explicit. We don't need join. We just need state and eval state. Okay, this all compiles again. Now let's do it better. We can use put to put stuff in a state. In this case, we're gonna put the n, which is with backoff, and length characters for now. Characters -1, but this is fine for now. We need to import put, and later we're gonna need get, so let's import get as well. So we put it in first parser or first attempt, and then we're gonna get and use it in the second attempt. So in the second attempt, we can get our n using get. N doesn't match because it's with backoff, not an int, but we can wrap it up. And so it kind of looks reasonable, ugly for now, but let's just think it through if it's gonna work. We're gonna put it on the first step. On the second step, it's gonna be n-1. We're gonna start and do the rest. And it's gonna just try once with only one fallback, not more. But I think for now, the idea of it is more or less looks possible. But we need to deal with different backoffs. Like it could be backoff 0, first attempt, is it backoff or not? When does it become none? Initial one should be none. So let's play around with this one. Let's extract it to make it nice and then make it better. So with backoff function, with backoff function is going to be functions that is just a parser for characters for specific cases, but we just need it for monad to work. So we're going to get, and then we're going to pattern match. If it's a none, the initial state with no backoff, first time we trying something, we're going to do one thing. If it's not the first one, we're going to do with backoff n. I think we can pass a parser here. I think let's just keep it a list of characters for now to make it simple. So if it's a none case, we're just going to do a parser like we did before. The first step, all of this, get characters, put a new backoff, and then do the rest. And then the second case, we're going to run with a count. Instead of using the normal one, we're going to run with a count. I think it's going to be our normal first case. And then let's just drop empty to make compile. For some reason, I put a slash on the wrong side. In case of the count, we still need to tell it what kind of parser we need to do, what number of counts. So we need to get a parser with a pattern, but we don't have it here, even if we join, because the parser way of passing is the current parser, not the next one, or not nested. This is not enough of a type. So now I want to be explicit that it's quantified pattern, so we can get access to the internal pattern and then following things. But we have multiple patterns, so we need to do different operation based on the pattern. We can extract inner pattern by pattern matching on this quantifier. So let's move this around. I lost this piece for one more. So together with the pattern, we can extract this greediest thing that they used to do before, and then the inner pattern that it has to do afterwards many times. So let's just call it greediest and inner. In the first case, we do this sum and this inner pattern, and then the pattern itself is char parser from. In the case of 0 or more, it's similar. We have this char parser from, we're going to do this optional inner. And in case of 0 or more, we're going to do many and the char parser from. In case of wildcard, I don't know, just inner, just does it itself, and then any single, I'm not sure. So in the greediest case, we're going to do greediest. And in the case of second attempt, we're going to do this count and with the inner. And it's a bit awkward because we have them both in the same ADT. Maybe we need to move it out later. Let's add an error here and there, which shouldn't happen, quote unquote, but it probably will. We'll just refactor later. For now, let's just keep it as a reminder. And then if we pattern match on n, we're going to do this. We're going to join count n. And then in the first case, in case of 0, we need to do a special case, but I'm not sure what we do first. So we extracted this current using get. Now we're going to know what we're going to do on the first attempt. Then we can apply this current parser and get characters as we did before. Then we're going to put it with the length character -1. Because now we're doing matching and counting there actually. We can try to see if before it was with backoff we can do -1 already of that one and not count, but I think it doesn't matter. We can just count it again. It's not a big deal. Then we do go rest, but we don't have rest, so we need to pass a whole chunk, maybe patterns. So we're gonna do current pattern and then the rest, so we can get the rest out of it. Oh, we're already running chars before. Yeah, we don't need to double bind. We can just have characters. We already run it from the first time. We bind and run it on the first go, extend the characters, and then we do the rest. And then the go is not a scope because we don't have go. Yeah, this is awkward because we kind of have it inside of it. Let's just indent it more so we can have access to the go and then untangle this mess later. So now more or less compiles, even though it looks terrible. So how do we use with backoff now? We need to actually add this try somewhere, do the trying and backing off. And the question if we want to do it inside of here or somewhere in a different function to make it nicer. For example, we can extract all of this into first, or call it the greediest first attempt, first match, and what we had before, all of this. And then we're gonna try this greediest match, or else we fall back to the backoff, some backoff match, which is just doing the same, like doing this second case. But we already done the removal, so we can clean it up, but that's what I'm looking for. I want try, do this, or fall back. We've already have this, it should be inner. So we get with backoff, then we do the join with a count. But actually, yeah, we don't need it. We just did it. Yeah, we can just drop it. With backoff, it's just gonna call itself because we already done most of the work. Just call itself because the state is actually inside the state. We just with exactly the same patterns, but the match is gonna do different things. We can call it greedy match. We get chars. We either run greediest or we do some other one with backoff. At the end, we get the end, update the counter, and do the rest. Otherwise, if it fails, we fall back and do everything again. The problem is that we have one state that cannot be shared across everything, so we kind of have one backoff at a time. Probably, maybe. I don't have the brain capacity to do more than that. Let's just add a comment. So with this backoff, we need to make it properly. In case we have empty patterns, we run to the end. We need to actually do all of it, not just with back off this part. We need to try in case we have different patterns actually. And then in case if it's empty, we just stop empty. And in case of with back off, let's put empty as well. This might backfire because empty just fails, I think. So let's see how it's gonna work or not. Maybe if we refactor this way, it's gonna look nicer. Just get current attempt or current back off pattern match and do it so we don't have this weird nestedness. Yeah, current back off looks nice. So this char parser from is our old function. Let's use our new one, the match pattern, the one that's gonna be clearer and cleaner. We can remove the old one, combination of both, and just use match patterns. It's gonna be just matching on these simple patterns. We don't even need to lift anything. It's gonna be just matching on the pattern. Once again, we'll put it on the left, and then just for one character. And it's not gonna do anything for these qualified complicated ones. So it's simple, just match something like a digit and do something else. And the type signature is going to be take a pattern and return the parser for character, not list of characters. While the other one is going to be more complicated and doing it from a list to a list. So inner one, we don't need those joins. It still doesn't match. Is it a character? A scope type variables. Let's add scope type variables. I think the stuff on the left also. We don't need any lifting and joins. MA with a character. Okay, let's add things here. So it's going to be a parser for a list of characters. Parser doesn't match with a character. Parser doesn't match with a character. We pass it and it becomes parser of characters. Oh wait, this one is parser, parser 2. Okay, if this is a parser, then we might need to leave this one because it's only one, not a list. And this one is also not working character, and a list of character is not working because we're using from maybe list. We can keep optional. Maybe is not working with list. Yeah, we need to convert this using maybe to a list. So now this one is working. Let's clean up the rest. In case of doing duplication here, we can use our match pattern here. We're gonna reuse it here, but all of this is gonna become with back off. Let's call it patterns. And then if we found the patterns and it's one more, then we just gonna call with back off on patterns. We're gonna do the same on the other two. In the case of 0 or 1, and in the case of 0 or more, and the wildcard should do the same. It's ugly now, but we're gonna refactor and do it better later. All of these are simple and can be simplified because they do the same thing. So let's just move it down for now. Call it a pattern, and then we can use match pattern to convert this and then do the rest. This pattern and then the rest, and then go do the rest. Looks nice, sir. It's not. The other four also screaming for update, but what I found annoying is the whole copy paste. So let's actually have something specific for quantifier. We can have quantifier, have it 1 for 1 more, 0 or 1, 0 more, wildcard, and maybe later for range. So instead of having all this, we're gonna have something quantified, and it's gonna be quantifier and a pattern. The initial parsing is gonna change. We can just wrap it in quantified, and the quantifier is here already, and previous pattern is also here. We need to export the constructors, go back and then import them as well, and all of them also become quantified. Updating this part was simple, and maybe we can also simplify it to just having any single parser and then flat map up and do the rest. This one not matching. Why? This also should be quantify wildcard. Why is it? It doesn't have a pattern. Yeah, I guess let's just make it optional. I don't know. Why is it so weird? And then have it like this with nothing. This is super awkward. We'll have to wrap all of this. What if we don't do this? What if we put it inside the quantifiers? Instead of having it here and then breaking, let's just give all of this a pattern. And then wildcard stays different as it was. And so all of this gonna have $1. This loses nothing, and then the parser part is okay for now. And now we can simplify here. When we have not just a pattern, but quantified pattern, we don't need to extract a single one. We can just say something quantified. And now we can say, okay, we found something quantified, do a bit with a back off. And then here we can simplify as well. We can just say, okay, quantified. If we got something quantified, we do this with back off, with the rest not quantified for some reason, just return empty. It's a failure. But yeah, so here we just have a quantifier. And now for this case, we can say, okay, if for some reason somebody called quantified here, we just say an error because it shouldn't happen. So you get an error. And having this go just there doesn't make sense. So we can inline and pattern match right away. If it's patterns quantify, we do with a back off. If it's just a normal pattern, we do match pattern and then repeat. And at the end, we do empty, and the go becomes match patterns. In this case, it's also match pattern, not a go. And now it looks reasonable enough to try. Let's try with a doc. If we get a doc, it tells us that quantified 0 more quantified, but it doesn't return. Probably gets stuck. Probably the recursion is not that great. Probably. Let's try to add some print to see what's going to happen. We're going to debug with back off. and a debug for the pattern case. In this case, I want to see what the pattern was. If we run it again, we're going to see that OG is getting parsed a lot of times and gets stuck. We have single, quantified, wildcard, single G. Wait, it's not quantified. Why is the wildcard quantified? Why did I copy pasted this? Yeah, that explains everything. Let's remove it. So now I can refactor it actually, and it didn't make sense because wildcard was not matching. So we can put quantifier to be quantifier, not wildcard. So I think I just had enough. So we can extract quantifier. Quantifier becomes here quantified as well. We can get quantifier and the pattern at the same time. So here we pattern match on a quantifier, but we don't need to extract the pattern. Wildcard also useless. I mean, not useless, but goes in the normal place because actual wildcard is just any single, which looks much nicer. And in this case, inner is just match pattern on a pattern. We don't need to do anything special for each case. It's just one because all of them just have a pattern. This could be simplified to just greediest. Remove all the match patterns. This is simpler, this is simpler. And if we try it again with a doc, we get unknown parse error. Probably somewhere from here. maybe the reason that it's because it goes in opposite order for some reason. Single, wildcard, and G. This should be simple cases. There is no backoffs here. Let's look our debug. So we have with backoff, match pattern, G, match pattern, just, so why is it G first? Are there parentheses wrong way around? Do I need to just, I want this. I want parentheses around this, not everything. Can we try again and see if it's, okay, now at least the order is fine. First we try D, then we try OG, and it's 1, we get O, and then G, and then it says that unknown parse error. I mean, we got to the end. Looks like it got all the letters. I assume empty is to blame because it just fails. If we open the docs empty, this parse fails unconditionally. Yeah, so unknown error sounds like what we have. Here we have all our traversal. In the case of quantified, we do quantified thing. In the case of pattern, we do just match pattern and do the rest. And at the end, we successfully failure regardless of what happened before. So to fix this, we need to do empty and make it succeed and just return whatever it was before. And not to get bumped into this unknown issue again, let's just add actual failures with messages, not just unknown messages. But let's call this one fail for unexpected and fail for here as well. So we have fail unexpected quantified and failed unexpected empty patterns. So at least we explicitly know where we fail. And then with backoff shouldn't reach 0 because it cannot match and just say, okay, I got 0. So this shouldn't get to the back of 0, a different failure. So if I try the doc now with the whole pattern with 0 or more wildcard, it should work, and it does. Now let's try something with 1 or more. If we try to match on the CAC with a cat, also gets stuck. So we have C quantified 0, 1, and then A and a T, and it gets stuck. So I think 0 or 1 doesn't like this treatment. Maybe it should be just a special normal case for 0 or 1. Let's try it for now. So we have quantified 0, 1 pattern. Let's keep this one for just special match quantified cases. And then here we're gonna have a special case for 0 or 1. Because we can match on this quantifier, and then instead of doing what we are doing for this backtracking, back jumping, we can simply say try to match a pattern with this pattern, and then this match pattern is what we have here with maybe to list optional inner. Inner is just match pattern pattern, and then match patterns rest as we do for everybody else. There's no back off or back jumping, just doing it once. Then we don't need these patterns. If I try it again, it matches, says that expected T and got a G, which is what we got. So let's try submitting it and see if this one works and doesn't get stuck anymore. Okay, another one timed out. Now we have act with a cat. This one also gets stuck, and this one is 1 or more. 1 or more A, and then instead of failing right away, it keeps retrying. Let's try to add the debugging parser in front of match quantified to see what's happening. And then debugging one in front of the pattern, this time with correct parentheses. And maybe let's show a pattern as well. If we run it, we see that we get act, and then fail. So pattern single fails. Do we even get any backoffs? Do we get out of this simple case? I just wonder if the character is the -1, or do we're not failing on 0, but why are we failing? And also let's just add the whole greediest step as well. Maybe on the original phase, and then all the fallback to see if it ever falls back or not. If we try this, we see that we get stuck with backoff is always none, and we keep getting stuck on the T, unexpected T, expecting A. Seems like we're getting stuck in the base case. If we keep failing, it doesn't matter if we do count less or less, we just never leave the loop and it just gets stuck and stuck again with this none. So we need to extract what we have now, but account for the errors. Actual errors, not just errors with retry and try less. So the debug function gonna get as it was getting before, and then if we match for the first time and the actual fails, we fail. So if it's none, we fail, and if it's with back off something else, we match patterns and continue with patterns. In this case, in the none case, we should probably propagate an error instead of just failing randomly, because we want an actual error. Not the best. Maybe just do it twice. We fail and then we fail again if we failed. I think probably there is a better way in the library to get your previous error, get it from the state or pass it around. But we can say something like failed to match. Actually, let's just do it again. If we failed for the none, let's just do it once, get the actual error. It's bad, but kind of losing the patience here, because I'm lazy. Now, if we run it again with our act and a cat, we get a failure that we wanted, unexpected T, we expected an A, so we can remove all the debugging. And let's actually try to submit, because we tried Wildcard, we tried this one, so in theory this should be good enough to pass all the tests. So if we submit and get to the end, it actually works and passes, which means we can go to the last challenge about alternations. So in case if we have something like a cat or a dog, we need to pass one. Now it's all just singles, but we need to do something similar that we done with groups. Let's have this cat or dog for reference. We're gonna have something like parse alternation. Because parse alternation will have to use parsers inside of it, we can extract parse one so we can reuse parsers for parsing the two alternations. We can add the pattern alternation, which is going to be pattern on the left or pattern on the right. And the parser itself is going to be first opening parentheses, then we're going to have this or, and then closing parentheses, and in between it's left parse one or right parse one as well, which then we assemble into alternation left or right. The problem is that we treat parse alternation separately, it might not allow nested alternation. But actually, if we put it as parse one inside, it should be possible. So let's just put it in as one of the parse one choices, and then we might be able to get away with alternation inside alternation. Simple patterns, left or right, but it's not gonna work because here we want a parser of a character, but we actually have already parser of strings or parser of list of characters. So maybe we put alternation as a special case. We have a case for quantified, case for simple patterns, and case for alternations. We'll just have to move it here, add the rest, match pattern left or match pattern right, and then go to the match pattern rest with a couple of parentheses. And it should be just match pattern and match pattern because nested patterns are just patterns, not the patterns. And if we run this, we get unexpected, A and OR. Probably because the parser alternations were not as simple as I expected. Why we have an unhandled pattern? Oh, is it because we need... Yeah, because inside we can have quantifiers and we can have many, not just one parser. Yeah, so we just get one and then we expect an OR, which means we're not parsing this fully or correctly. I think this one should be many, but many is also followed by quantifiers, so we need to move it out. We're gonna move out this parse many and put this many parse one or parse quantifiers, and we're gonna use this in this case. The pattern and patterns is not matching anymore because we added quantifiers. And it's actually not working as well because we have now starts and ends inside of it, so it doesn't make sense. Let's just keep it with parse many. With parse many is just a parser for patterns. We're gonna use this one there and use it here. And instead of having pattern or patterns, we're gonna have list of pattern. Sorry for the naming stuff. We just change match patterns to match patterns as we copy paste it originally. In this case, we get unexpected end of input because we consume too much, more than we wanted. So we need to say that this single character is not a single character, but actually a reserved word. We have reserved, and it's going to be $, parentheses, square brackets. And then to make it simpler, we can add another function for any non-reserved. That's going to be just none of reserved. And it's going to be parser for a character. We can use any non-reserved inside the parse single. Let's also add a caret before I forgot. We can also use any non-reserved inside the character groups, add the try for all the parse manys, and try it again. So what do we have here? Parentheses, pipe, parentheses. Oh, the pipe. And also pipe is reserved and we should skip it. This time we get a dog, alternation cat or alternation dog, and it matches as expected. If we try it with the cats, cat or dogs, it also matches. We can drop some comments and move parse one inside parse many to make it cleaner, commit, and get a successful result. Phew, alternations are done, and base stages are complete. Before we wrap up, I want to recap what we did. So first of all, we looked at the whole CodeCrafter challenge, once again to try building something with Haskell. As a reminder, there is an affiliate link in the description, but also as you can see, there are a couple of challenges that are free this month. I've seen recently that they announced that the building your own shell is also free, not for Haskell, only for Go, Python, and Rust. But if you want to give Rust a try and then tell everybody that it's better than Haskell or not, this is another option to give it a try for free. But let's go back to our solution. So we done a simple app that parses a pattern first and then uses some intermediate ADT representation for a pattern. A bit awkward one because we have simple pattern together with quantified patterns and alternations and wrapped around in patterns with optional start and then anchors. And we had some troubles with all of this here and there. After parsing the pattern, depending on if we were successful or not, we were matching the pattern using another parser. So in theory, we could have done it in one go without intermediate representation, but we have what we have. So in the pattern phase, we made parse pattern that parses start anchor, then many patterns, and then the end anchor. Parse many chooses one of the possible things that we implemented. Some are like alternations, quantifiers that are also looking at the previous pattern and maybe the next one and wrapping them in maybe quantifier. And then a bunch of them were just simple patterns, looking 1 or 2 characters at a time, sometimes between the characters, falling back to some optional, some not, some simple, some less simple. We also had reserved that we only used them in the end. So probably half of the things were not actually working with the keywords, but I guess it was fine. And after all of that, we spent a bunch of time in the pattern matching module. We added a backoff, which we used in the state. This backoff may or may not work for more than one quantifier, but it was quite fun to implement because we tried to do it in 3 or 4 different ways. We tried the Go pattern a couple of times, we rewrote it back and forth, but at the end we got this parser that tries to match patterns and adds optional with start, optional with end, match patterns behaving differently depending on the pattern we got. It was either matching quantifier, either using an alternative, or using a simple pattern and then doing the rest of the pattern. We have a couple of interesting bugs here with empty because we were using empty and failing. Match quantified case has the most failures and questionable cases like this one. Probably don't even need one because we're never gonna get there, but it's still there. We have some performance issues, but overall it doesn't look that bad.